Hi guys, in today's video I'd like to go over review problems 30, 32, and 33 from the Unit 1 Rational Numbers Review Package. I'm going to skip 31 and do a separate video for 31 all on its own. But before we get started, I wanted to take a look at how to simplify exponential expressions. So here I have negative 2 to the fourth power, the quantity of negative 2 to the fourth power, negative 2 to the third power, and the quantity of negative 2 to the third power. Now, when there is no parentheses around the negative sign, then it means that this exponent 4 is just attached to the 2, which means we're going to take the opposite of whatever 2 to the fourth is, because that's what it means to have this negative sign out front. We're taking the opposite of 2 to the fourth. In part B, the parentheses is around the negative sign, so that means that negative is attached to this base of 2. And so that means that I'm taking negative 2 and multiplying it times itself 4 times. So let's take a look at what this means for our final answer. In part A, what we're really doing is negative. We're taking the opposite of 2 times 2 times 2 times 2. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So really what we're doing is we're taking the opposite of 16, which is negative 16. So our final answer in part A would be negative 16. Whereas if we look at part B, the parentheses is surrounding both the negative and the 2. So that means that the negative is attached to the base. And so what this means is negative 2 times negative 2 times negative 2 times negative 2. Here we have to take into consideration the signs as we go. And so since I have 1, 2, 3, 4 negative signs, and that's even, I know that my overall answer will be positive. And just as before, 2 times 2 is 4, times 2 is 8, times 2 is 16. So my answer is positive 16. Notice that when the exponent is even, then I get different answers. I'll get a different answer if there's no parentheses versus parentheses around the base number. So in part A, I got negative 16, whereas in part B, my final answer was positive. Now, if the exponent is odd, then even though you may end up with the same answer even if you don't do the problem correctly. So I want you to really start thinking about what these mean so that you can complete the problems correctly. But again, let's see what it looks like if the exponent is odd. You could accidentally get the answer correct. So here, again, we have negative 2 to the third, so that means we're taking the opposite of 2 times 2 times 2, which means we're taking the opposite of 2 times 2 is 4, times 2 is 8, so the opposite of 8 is negative 8. In part D, the whole base is negative, so the negative is attached to the 2, so this means that I'm doing negative 2 times negative 2 times negative 2. Here we have to take into consideration the signs. So we have 1, 2, 3 negative signs, that is odd. Therefore, my overall answer is negative. And 2 times 2 is 4, times 2 is 8. And in this case, when the exponents were odd, then we ended up with negative 8 either way. But again, you would end up at negative 8 for the wrong reasons if you did not recognize whether or not that negative sign is attached to the base. So please kind of watch out for that. We need to know that for the next couple of problems. So let's take a look at problem 30. Here we want to simplify the following expression, and we've got exponents, we have parentheses inside of parentheses, and so what we're going to do is follow PEMDAS. So that means we're going to take parentheses, exponents, multiplication or division, left to right, whichever comes first, and addition or subtraction, left to right, whichever comes first. I'll even highlight these colors so that you remember that the multiplication and division is on one level and addition and subtraction is on a level by itself as well. So now let's go ahead and follow this through. All right, so I know my plan is going to be to first take care of the inside of this parentheses, which is -8 plus -6. Then I'll take care of inside of the second parentheses, which is 1/4 minus 3/7. All of this is inside another set of parentheses. So once I get these two parentheses simplified down, then I will multiply them together. Next, I will simplify this exponent, and then finally I'll multiply everything together. So I first want to create just a little space so that I can complete my scratch work, and then that way I can keep the area that I want to use for showing my work nice and neat. So for the first part, I'm going to take -8 minus or plus -6. So I know here that I'm going to scan through to see whether or not I to make sure that I have just exactly one sign in front of each number. So here I have one sign in front of the 8, which is good. I've got two signs in front of the 6. I only want one, so positive times negative, I can replace that with -6. And then of course I can stack the numbers. The signs are the same. I'm going to add them up and keep the sign. So this means that I can replace all of this with just -14. Next, I'm going to take the items inside of the parenthesis that's in green and simplify that down. So here we have 1/4 and 3/7. So what I'm going to do is I'm going to take 1/4 minus the 3/7. I know I need common denominators, so I'm going to do 7 times 1, which is 7, 7 times 4, which is 28, minus 4 times 3, which is 12, 4 times 7, which is 28. There's no sign in front of the 7, so I can assume that it's positive. And to simplify the numerators, I'm going to take positive 7 minus 12. So again, I'm going to go ahead and stack -12 on the top, positive 7 on the bottom. The signs are different. I'm going to subtract and keep the negative sign, so I can rewrite this as -5 over 28. So now I can go ahead and place that -5 over 28 inside here. And all of that is inside parentheses. Bring everything else down. Well, now I've got a fraction, and I'm multiplying it times an integer. So I want to go ahead and change this to a fraction. Right away, I notice that 14 and 28 can both be divided by 14. So 14 divided by 14 is 1. 28 divided by 14 will give me 2. That way I can keep my numbers from getting quite so big. And if I multiply across the top, I'll get -1 times -5, which will give me +5, and 1 times 2, which will give me 2. Bring everything else down. Next, I have -4 to the third power. So this really means that I'm taking the opposite of whatever 4 times 4 times 4 is, and then I'm going to multiply that times 5/2. 4 times 4 is 16. 16 times 4 is 64. So this is really -64 times 5/2. And again, I have a fraction and an integer. I want to change this to a fraction by putting it over 1. And right away I see that 2 and 64 can both be divided by 2. So 2 divided by 2 is 1. 64 divided by 2 is 32. So now we can multiply negative 32 times 5, and negative 32 times 5 will give me negative 50 times, or 30 times 5 is 150, plus 10 more is 160, and 1 times 1 is 1, and negative 160 over 1 is just negative 160. So if I simplify this expression, all of this will be equal to negative 160. Okay, let's take a look at the next problem. Here we want to simplify negative 1 to the 5th power. We have the same situation. This negative sign is not attached to the base because it is not in parentheses. So that means that we're really taking the opposite of 1 times 1 times 1 times 1 times 1. All of this is just going to give me 1. And so the opposite of 1 is negative 1. So the answer here is negative 1. Now, you could have done this incorrectly and still got the same answer. This would not be the correct method, but you just would have luckily ended up with the right answer. And if you had done that, if you do this process, you would only get 1 point for the right answer, but the process, you wouldn't get full credit because the process was not right. If you happen to do negative 1 times negative 1 times negative 1 times negative 1 times negative 1, then you still would have ended up with an overall answer of negative 1, but the process is incorrect. So we do not want to do this. We do want to do this. Okay, let's take a look at our final problem. We have the decimal equivalent of 7/8. Now, I would like to do this problem using 3 different methods because 3 ways kind of jump out at me. The first way is to just use long division. So I know I have 7/8. I'm going to keep the 8 on the bottom. The 7 falls off the top. 8 cannot go into 7, so I'll put a 0 here. And if I want to keep going, write a decimal, add a 0. 8 goes into 70. 8 times 8 is 64. I have 6 left over. Add a 0. Bring it down. 8 goes into 60. 7 times 8 is 56. I have 4 left over. Add a 0. Bring it down. 8 goes into 45 times. So the decimal equivalent of this is 0.875. Now, we could have also come up with the answer by using benchmark fractions. And the first way that we could have used benchmark fractions is that we know that 1/8 is equal to exactly 0.125. So therefore 7/8 has got to be equal to 7 times this amount. So if I would have taken 0.125 and multiply it times 7, I should get exactly the same answer. So 7 and 5 is 35. 14 and 17. And finally 8 and 0. Move it over 1, 2, 3 times. So I still get 0.875. Now the third way that we could have looked at this is that 1 whole can be written as 8/8. Minus 1/8 would give me 7/8. And not 7/8, 7/8. So if I wanted to figure out 7/8, I could actually take 1 whole and subtract my benchmark fraction of 1/8, and I would still get the same answer. So 8/8 can be written as 1 point, and I'll add as many zeros as I need, minus 1/8, which is 0.125. And then if I subtract, I will end up with 5, 7, 8, 0. So this just shows you that changing fractions